Okay, folks, fair play to you for staying patient and with me so far. It's the final video in the series, video 7, future work in neuro-machine translation. So this is quite difficult to predict, when we think that, here's a nice example I saw, fairly recently in Twitter, things that didn't exist, 10 years ago. Look at that list of things there. So it's very difficult. We're in turbulent times in more ways than one. So it's very hard to make predictions. But when we apply for more funding from funding agencies like SFI, they do ask us to write grant proposals, which bring us up to 2026, for example. So we have to try and make predictions. But when you think NMT really wasn't mainstream, even 4 or 5 years ago, it's quite hard to predict where we'll be in 3 to 10 years' time. But it's safe to say that neuro-machine translation isn't going away. Everybody's working on NMT nowadays, especially in academia. So, we're all working on the same problems, trying to, solve, neuro-machine translation issues and make the quality better. Don't believe anything you read that neuro-machine translation is so good that's going to put humans human translators out of work. That's not going to happen. You can look at the output yourselves and see sometimes that NMT will hallucinate words, and you just think, well, where on earth did it get that word from? It hasn't got any basis for predicting that particular word given the words in the input string. But anyway, these sorts of mistakes do happen, and they're quite difficult to predict. So the human in the loop, as always, will be the most important factor in translation pipelines. As the translation improves, evaluation metrics are finding it hard to keep up. So if you look at the comparative score between an SMT system and an NMT system, you might see like 2 blue points of difference. But if you conduct a human evaluation, the humans will say that the NMT system is much, much better than the SMT system. So arguably, we need to come up with new evaluation metrics which accurately predict the delta between the performance of an SMT system and an NMT system. Given that we need more and more data to train up our NMT systems, as we did even with SMT, so data selection is a hugely important topic. We in our team do a lot of work on user-generated content, which will continue to increase. We all contribute to this. We're all suffering from content overload, but we're all publishers nowadays on various social media platforms that we subscribe to. And engine training times are very long and need to come down. So parallelization might be an important topic. So, human translators are beginning to work seamlessly in line with NMT, which is, which adapts well to user data, learns from post-editing. And so the human can enjoy enhanced productivity and a better user experience. So, we've done this sort of thing with a range of industry partners, on the basis of a few hundred edits that a human translator might have made to some machine translation output. The system can start to learn from those edits as to what sorts of translations the human translator prefers, and can start to produce translations that she prefers over maybe the default translation produced by the MT system. So this is quite straightforward for us to do nowadays, and it works in real time. And then the translator can see the direct benefit of providing feedback on the quality of the NMT system as input to us as the designers, who can then improve the system for that particular end user. Neural automatic post-editing, as I've just shown. Multilingual MT, where this is a very interesting one, where we don't have parallel data for all of the languages. Let's say we have English Italian data and English Romanian data, and as a result of that, the multilingual system is able to infer correspondences between, let's say, Romanian and Italian. A lot of this is called zero-shot translation, and it's very, very promising. So this is kind of unsupervised machine translation, and it's working really well. It's about 4 years behind where the supervised MT was, just 4 short years ago. So it's coming up fast, and it's very, very promising. So just to summarize then, Neural MT has rapidly kickstarted a new area, significant improvement in performance, but exaggerating hysterical claims, especially from some of the major online MT providers like Google and Microsoft. As I say, everybody's working on these topics. If you look at Archive and other online publishing modalities, new ideas are coming out pretty much every week or every month. So we have to keep an eye on all of these improvements that are coming thick and fast. But machine translation isn't going away as a problem. It's better than it's ever been, but there are lots and lots of issues still for us to tackle. As I've said, the sequence-to-sequence learning of MT, sequence of source language words and phrases needing to be translated into a sequence of target words and phrases is very, very similar for a range of other applications, and some of them are on the screen here. So if you are not so interested ultimately in translation as an application area, then one of these other areas involving sequence-to-sequence learning uses the same underlying technology and architecture that I've explained today. So if we end with an analogy on self-driving cars, technical translation is relatively straightforward to do, and just cars driving along a motorway, keeping their distance between the car in front and staying in lanes. We can do that nowadays. Creative translation, which humans are very good at, is difficult for us to do as machine translation practitioners. And then, we have the traffic situation in India, which is an analogy to show that machine translation, perhaps of all the computational applications, is perhaps one of the hardest problems that we're trying to solve computationally. So a bunch of references up until around 2017. There are many more newer papers that have come out. You can check out even the work that we do in our MT group on my website. But I hope you've enjoyed these videos. NMT is here to stay. It's surpassed the quality of SMT. We, hopefully have shown you, how NMT is improved from the early models, the early feed-forward models, to the recurrent models of today, and the state-of-the-art, which is essentially an encoder-decoder architecture with an attention mechanism. So hopefully you've enjoyed these videos. It's the best we can do in the circumstances. I'll set up a Zoom call or some other way in which you can get in touch to answer any questions that you might have on any of the material that I've covered in these videos. So hope you all stay well, and we'll keep looking after you, but do share your feedback on what we've tried to do here today.